Hi, welcome to a lesson about basic history of x86 architecture. Objectives of the lesson. You will learn about the first processors in the x86 family. You will be introduced to the concept of backwards compatibility as it applies to the x86 processors family. You will know about some of the different modes being used in the x86 processors. A quick reminder about processors. The processor is the heart of a modern computer. A processor is an electrical component that has the following functions. Read instructions. First, the processor always fetches an instruction from memory. An instruction is a very basic idea of something to do. Some very basic task to do, like add two numbers or subtract two numbers, or maybe store something in memory or read memory. The processor first reads an instruction and then it executes the instruction. It could be many things. Like said before, it could be some kind of arithmetic calculation. It might be reading or writing from or to memory, or it could be some kind of input or output. Like maybe the processor wants to communicate to some other components in the computer. The instructions to be executed are written ahead of time in memory. That means that we know ahead of time the list of tasks that we want to do. We write all those tasks or instructions in memory and then give it to the processor. The processor goes over the instructions one by one and then executes each of them. The collection of instructions in memory is called a program. Basic history of the x86 architecture. x86 is a general name for a family of processors. All of those processors can understand more or less the same program instructions. You can take from this point that x86 is not just a single processor. It actually means many processors. There are many processors that comply to the x86 idea, that actually implement the x86 basics. Intel introduced the 8086 processor in 1978. This is the first processor in the x86 family, and it is based on Intel's 8080 8-bit processor. It is primarily developed for embedded systems, small special purpose computers, and other small single-user computers. It had 16-bit support. Just for some clarification, if you never heard of it, embedded systems are usually small computers that are meant to do mostly one thing. For example, a router. Have you ever seen a router? It's one of those machines that takes packets from the internet and forward it to other places. Some other kinds of embedded systems might be the computer inside your car, or maybe some small chip inside your hard drive in the computer. About the 16-bit support, we are going to speak much more about this in the future, so don't be afraid if you don't get it right now. It actually means that this processor, the 8086 processor, was one of the first processors that had the 16-bit support. It was the first one in the x86 family that had this support, and that means that this processor had the ability to process data of size of 16 bits. I remind you that we are talking about 16 binary bits, like we learned previously. This is a picture of the 8086 processor. Generally, this is how a processor looks like. It's just some kind of electrical component, and it has all those legs. It can be put inside bigger circuits so that other components could communicate with it. Intel 8386 processor was the first in the series to be 32-bit compatible, and it was introduced in 85. In 2003, the AMD company introduced Opteron, which was the first x86 compatible processor with 64-bit extension. It was the first x86 compatible processor that had the ability to deal with data of size 64 bits. Intel adopted AMD's architectural extensions into its next processor designs. Here we can see two pictures of processor. This is the Intel 8386 processor. You can see the 386 numbers here that represent it. And here we have the Opteron processor made by AMD. This is how it looks like from the outside. If you ever open a computer and see something like this, you could recognize the processor. Today, in 2014, x86 based processors are very common in stationary and portable computers. x86 processors are produced by many different companies. That means not only Intel and AMD, there are other companies that create x86 compatible processors. Many stationary computers and laptops ship with an x86 based processor. Also, most operation systems can run on x86 processor. When we say it can run on x86 processor, that means that it has a version with code that's meant to run on x86 processor. That means that it has a version with instructions that comply with the x86 processor's family. Some examples of well-known operation systems that support x86 are Windows, Mac OS X, and Linux. It is most likely that the computer that you currently use has an x86 processor or something that complies with x86 processor. And I say that with the hope that you see this in about 2014. Who knows, maybe in the future it won't be a correct claim. Backwards compatibility. That means that programs that once worked on an old processor will work on newer processors too. This is very important. It makes it much easier for developers to upgrade their programs. For example, if I wrote a program for an old processor, and then a new processor was shipped, and I want my old program to work on the new processor. If the new processor has backwards compatibility, then I could just take my old program, put it in the newer processor, and it will just work. It would be much easier for me as a developer. This is mostly how it works in the x86 family of processors. Maybe it is one of the most significant characteristics of the x86 family, the backwards compatibility. Backwards compatibility was mostly preserved since the 8086 processor. Actually, programs that ran in 1878 on the 8086 processor can basically run today on the newest x86 processor. We have this star here because it's not really true, but basically it is true. The syntax is mostly the same, and for the most part you can actually take some old program that used to work in a very old processor and take it and run it on one of the newest processors in the x86 family. And this is mostly amazing. I think this is a remarkable property of the x86 family. x86 backwards compatibility is said to be a major factor in the widespread adoption of x86 processors today. As a drawback, backwards compatibility sometimes forces modern x86 processor designers to take strange design choices. That means that when you use the x86 processors, even as a programmer, you can see a lot of history in it. You can see lots of strange things that usually have some kind of historical explanation, and sometimes it is hard to predict when you look at something mostly strange and try to understand why it works the way it works. I hope that we will have even more time in the future to discuss those kind of things. You're going to see some interesting things in the x86 processor. x86 processor modes. x86 processors have several modes that help with the backwards compatibility. New x86 processors work just like older x86 processors, but they have more operation modes. The idea of preserving backwards compatibility and making every new processor work just like the older one but adding just a few features is mostly hard. The idea of modes really help with it. How does it work? It is something like this. Whenever a new processor comes or ships, the new processor has just the same features as the older one. Actually, it works mostly the same like the older processor, but it has new modes. And if you want to access those modes, you have to do some things. Then when you do those things, you get to the newer mode and you have new features. This new mode is non-existent, for example, in the older processor. We will look at some examples of some kind of modes. Real mode is the operation mode of the 8086 processor. It has a very limited memory access. Just for example, you can access to less than 1 megabyte of code and data, which is very unfortunate. Programmers that used to program to the 8086 processor in the real mode, they had many difficulties because most of the time it's not very easy to put all your code in such a small place. Strictly speaking, 1 megabyte is much of an exaggeration because they usually had less than that. They maybe have 64 kilobytes of code and data, which is kind of hard to handle. 1 megabyte is even kind of okay in some cases. These days, every x86 processor starts in this mode. What does this mean? It means that when you restart your computer, for example, or just connect it to the power and then press the button, your processor, if you have indeed an x86 processor, no matter how complicated it is, it begins in the real mode. And then slowly the BIOS and then the operation system make the necessary steps to move to the next modes. In the next modes allow the processor and the operation system to do more complicated things. Another mode is the protected mode, which is in fact the mode that we are going to know pretty well in this course. It was introduced in Intel's 8286 processor. The advantages of this modes are, for example, access to larger amounts of memory, even much larger amounts of memory. For example, you could access 1 gigabyte in the 16-bit mode, and as we are going to mostly work in the 32-bits world, we will have even more than 1 gigabyte. I think usually we are going to have about 2 gigabytes of memory accessible from your program, which is a lot. In addition, it provides memory protection, which mostly means for you at this stage that it helps the operation system manage a multitasking environment. I assume that you are so used to multitasking environment that you might have forgotten, or maybe you have never understood or known what it actually means. For example, it means that I can open a few programs in the same time. For example, here I opened many calculators and they seem to work simultaneously, you see. We have this program and this program and this one, and it seems like magic. Like, we have only one processor, at least I have only one processor at this point, but somehow I can open as many calculators as I want. And they just keep working at the same time. The protected mode of the x86 processor helps the operation system to handle these kind of situations where many programs have to work side by side in the same system. For example, it helps the operation system to protect the memory. That means that if I have two programs that run at the same time, they cannot corrupt each other's memory. If one program fails, it only fails alone. It doesn't fail the other program, for example. The long mode. which is introduced since the AMD's Opteron processor that we actually talking about in one of the last slides. The most important feature of this mode is the ability to handle data of size 64 bits. When you hear about 64 bits processors, mostly in the x86 family, it actually talks about the long mode. We are going to speak less about this mode in this course, but it's not very hard to migrate from the protected mode to the long mode, which are mostly very similar. They are just a bit of new instructions and some other names to some things, but mostly they are pretty similar in one way or another. And of course, there are more modes. I mostly did some oversimplification of things in this slide, but maybe I just had to do it because this is really the beginning. After you do some code writing in protected mode, you will have more experience and you can understand the other modes. We are learning backwards. The long history of x86 processors could make them seem a bit complicated at first sight. It might be true, but don't panic. We are going to handle everything that we see and we are going to make it. You don't have to worry about it. We are going to learn from the end. Protected mode and long mode are easier to deal with in the beginning. That's why first we are going to learn about the protected mode in 32 bits. This course is going to be about the protected mode and mostly working in 32 bits. The operation system deals with most of the earlier modes of the processor for you. That means that most of the time you will be programming in protected mode or long mode. Protected mode if you want the 32 bits and long mode for the 64 bits. Usually you are not going to deal with real mode unless you want to write an operation system or a BIOS. Mostly usual people do not deal with real mode. If you really want to deal with it, I still recommend you to go through this course first, so you can understand how regular assembly language looks like. And then you can deal with the real mode, which is not that different from the protected mode. Most of the opcodes look the same. It's just that in real mode you can do more low-level things that in the protected mode are not available to you. Learning to program in more recent modes, for example protected mode and long mode, will give you a strong basis to approach real mode and other modes later, in the future. And that is if you want to. You might want to do this. For example, if you want to do something really tough, like writing an operation system, or maybe look at the code of an operation system, or make modifications. Maybe you would like to look at some code of a BIOS system, which is really low level. Then you will have to understand a bit about real mode. And you can do this. It's not very hard, it's just not dealt with in this course, which is more basic. It's more like an introduction to the x86 family. Thank you. I will see you at the next lesson.